A particle of mass m and charge q is projected into a region having perpendicular magnetic field B. Find the angle of deviation as shown in figure of the particle as it comes out of the magnetic field if the width d of the region varies like in part ABC. Fine. Now first of all, let me tell you that if a particle is projected with a velocity v in a magnetic field, then the radius of its circle will be given by mv by qb. Fine. Now first thing, that if the width d is smaller, slightly smaller than mv by qb, right, then what will happen? It will trace a curve like this. Let's say this is my angle of projection. Fine. This is my center, right? Now if d is very slightly smaller than mv by qb, slightly smaller, this is not the right, Mr. slightly smaller, fine, then I can assume that d is almost equal to mv by qb, almost, not exactly but almost, fine. So if it is so, then d is equals to r, right? So if d is equals to r, then what will happen if I project it like this? Then it will trace a curve, but d is just less than r, so it will leave the magnetic field at this very point and go in this direction. So the deviation angle is pi by 2. Fine. Theta is equal to pi by 2 for 1. In second part, when the radius is equal to mv by 2 qb, fine, when d is equal to mv by 2 qb. Now of course it is less than radius, so the circle cannot be completed, or even the quarters cannot be completed. Now let's say this is my center of the circle, and this is what is happening. Now this angle will also be theta, right, because this angle is 90 degree. This is a tangent to a circle, this is the radius, so angle between the tangent and the radius is 90 degree, so this angle is theta, right? Now I have to calculate theta. I have the value of d. Let us draw this line. This is my r, fine, and this can be written as d. So I can write sine of theta is equal to d by r, that is perpendicular upon hypotenuse. So d is mv by 2 qb and radius is mv by qb, so it comes out to be 1 by 2 is equal to sine of theta. So theta is equal to 30 degree. This is the answer for the second part. And in third part, it is given that d is equal to 2 times of mv by qb. So it is 2 times of radius, so it will be the scene like, let's say this is my magnetic field, this is the width d. So if particle is projected from here, then it will easily complete its quarter, it will come back and go straight from here. So the change of angle of deviation will be equal to 180 degree. That is the answer.